Hello, today we're going to make Up300 printer quiet, and we also include a jam detection system for the filament, so it will not going to miss any print. So let's get started. So just like with Up300 printer, we're going to use dynamic drivers. Now this board is optimized for 46 volt operation, but I will run at 24 volts. I've also used voltage PWM mode, so it's the quiet one. I also disable the auto scaling, so I will tell the PWM controller that only based on the frequency you should increase the PWM duty cycle. So in that case, it doesn't even try to do current regulation. It only does based on the step time. So if step time decreases, so pull strain will get shorter. That means that it will start to expand the PWM signal, and it will have offset. So it's like simple linear equation. So more speed, more current, low speed, just offset. It also that makes it possible to increase the current when the motor is spinning, because you need to do much higher mechanical work. So that will increase the precision and reduce the current draw in the steady state. I also track the power with a 555 timer, not a power, but a power usage, let's say. So if this board does not see any step signal for like 2 minutes, it will give a third or even fourth of the current for the motors. So they will run cool when we are not used, and they will go hot when we are used. So that's very, very simple. So what I have, of course, 4 outputs for the printer. One input directly for the Cetus controller, that's basically the same controller. I have power, I have the encoder, I have relay with buzzer. So relay will shorten or open the circuit for the printer, so printer will know that it's run out of the filament. But I will use not only that run out feature, but also the jam detection. So if the filament is existing inside the tube, but it's not turning like motor requested, because I have the inputs of the step there, step and direction for my extruder controller. So STM32 will count how many turns the encoder has turned and how many steps is asked. And if it sees the slippage for the 2 times, because it's also you have to be very safe, because you can see the error, but it's still printing. So we have to just be very reassuring that yes, the filament is jammed. So it will open this relay, and the printer will stop. So this feature same tons of prints. So I don't know, for some filament it is jamming, and this helps. And I also have all the iteration of this slip detector. So that's nothing more than the simple shaft with 2 silicone O-rings, and we route in this groove, and it is also supported by this bearing, so it will reduce the friction, and it is turning a 12-bit encoder, 12 bits per revolution, and this microcontroller tracks it. So it's very simple. I get through quite a few iterations. So basically all the iteration is to get the distance of this bearing from the surface. So it's not increasing the friction too much, but it's also tracking very good. So yeah, this is the evolution. Started with simple design, then I added some holders, added a push button, then I realized I don't need push button, because if there is no filament, it automatically will be detecting. And yeah, so this is the last one, printed in the Polymaker PC Max filament. So it's very hard to print, it's very warping, but I was able to print it. So I'm very happy with that. This is the first print, you can see the warping. So let's assemble the slip detector mechanism and install everything inside the printer and see how it performs. So this is all we need to assemble the slippage detector. So we have all the parts. So let's assemble it. So first thing is, this is the simple part. This is 2 O-rings and shaft and the holder for the O-rings. So it goes in here. Like that. Second is the filament guide. So distance is very crucial, because too much distance, too much drag, too less distance, too less registration. And And after that, we just put this one on this side. Simple. We have a few screws, M3. Yeah, the encoder is very cool. How it assembles it's like Legos. You will see soon enough. Okay, add all the screws. Okay, so the cool part is, first we place, this is a special sleeve, this is for the 4mm shaft. You get multiple of those in different sizes. So you have a tool, you place it in here, you press the shaft, the sleeve, and then you secure it with the second sleeve. Then you place this adapter and place a few screws. Let's use on the far side. I also the head was too large, and the encoder was not snapping to the full location, so I have to file it down. So let's keep it floating just a tiny bit. Then you use this tool to align the shaft, so it just rides on the special edge, and then we just screw it down. Okay. After that, simple. We just place the encoder, and it snaps. And let's see how it works. So it's quite low resistance. And the last thing, we just need to add the tool. I have it here. So it just for the filament guide. And tighten the screw. And that's it. The filament gem detection system working. And because I have stepped in there, I can calculate not only the feed but also retract. So it does not register retract. And I also have the loop, so I have some hysteresis. So this is why I have to be safe on my levels for the detection when it's trip on. So very simple and very functional design. So let's put it on the printer and test it, and yeah, project is finished. So I made this test stand to test the programming, and it's very simple. I just generating step signals for the motor driver, and I have two counters. One is for the encoder in encoder mode, one is for steppers. So each time it sees the step, it's increment. If direction is 0, it will decrement or something like that. So it's full implementation of the step ender and the quadrature encoders to the counter. So stop generating 1 kHz, so it will start turning. As you can see, it unwinds at the same time. And now, if I jam it, so the idea is it measures for the 3-second time. So if it jams, it will say. And now, it's still working. So if it sees the jam, it generates the pulse. Now printer, after first generation of the interrupt, will cut printing. So I don't need any more timeouts or anything like that. If this one encoder is turning much more, code will ignore it. It only cares if motor is spinning first. If it spins like for 2 seconds, if it ever spins for 2 seconds, only then it's active, because I can do like insert a filament, and I don't want this measurement to say, hey, you have mismatch between a requested and the supplied filament. So I only care if when this motor is turning, and this one does not see any counts. So as you can see, the system is very simple. It just counts the difference with I don't even need to do anything. The filament is run out, and it will start to generate the symbols. And okay, so I have no filament, and let's turn off the scope. So let's turn off the generator, and now it should be off. Okay, as you can see, perfect. So it works very well, it's very robust, and the program is very simple. Only idea is this counter it's counting up, and if it's not matching, so idea is slippage factor right now is 2 times. If this is requested like 1 millimeter, and 2 millimeters, and this one sees only 1 millimeter, that's the threshold to say, hey, something is wrong. And after in this 3-second period, it will generate the interrupt for 1 second. So that's it. It's very simple, elegant. And also just printed this jig to hold everything inside. This is why I love 3D printing. You can create jigs to do all kind of stuff. And it took like 30 minutes to print on my printer. So very nice. Okay, so let's install everything in printer, download the firmware to the microcontroller that is inside the printer, and see how it goes. So I was printing with dynamic drivers and at higher speeds at turbo mode, and something is off. You just feel it, something is not right. And sure enough, I measured the resistance of the coil. It's 28 ohms. Now 28 ohms means a lot of turns. A lot of turns means a lot of back EMF. And if we have a 24 volt power supply and 28 ohms, you cannot push the current. So I will have to increase the voltage of my drivers to like 35 volts, because look, if I turn it slowly, even slowly like this, let's give a quick turn like this, I have 20 volts back EMF. So if I'm pushing if I'm using the voltage mod PWM signal, at this rate, I'm not pushing any current, because back EMF is higher than my power supply voltage. So what I have to do is increase the voltage of my drivers. So in dynamic drivers, I'm using auto scale off in PWM config. I'm using very high gradient for the PWM. So when it's turned, the PWM duty cycle will increase rapidly. And when it's off, when it's not turning, I use offset. It's small current, because at very low speeds, even tiny current it's holding very strongly. But at higher speeds, current just drops very fast. Look at that. Simple turn, 10, 20, 30, 40 volts of back EMF. So that's not good. So I'm very glad I was able to take one of motors out of this printer. It's from X-axis, I think, because we are the same. We are 28 ohms of resistance per coil. We are very high torque at lower speeds, because you don't need to turn it very fast. But yeah, we need much more voltage than 24 volts if I want a good, because what happens when it starts turning, the current can remain the same, but the motor starts to generate the voltage, let's say like that, and that means the total power, total mechanical power will drop, because it's like just battery in series with your power supply. So that's not good in the different polarity. So if I have to manually tune this motor for my speed. So idea is the current will increase when speed is increasing. So the power and let's say the mechanical power will remain the same. and I will have higher torque at higher speeds and lower torque at lower speeds to prevent this motor from overheating. So good, I was able to take it out, so I will have to resolder capacitors on my board to support 35 volts, and I will have to add another power supply just for drivers. And that means printer should be better, because it even at turbo mode it should track better the trajectory that G-code is representing. Yeah, so that's short theory about back EMF and the torque. So we use this template to simply drill the holes like I did before. It just snaps in here with a double-sided tape, and you just drill holes and it's done. And it took like 1 hour to print, so, and the holes match perfectly. So let's install the driver. So we have to use 6 screws, and it will be very sturdy, and also we'll use this metal sheet as a heatsink as a bonus. So let's do that. Okay, so everything is installed inside the printer, and so let's test it. So it will be, I think, a bit dark. Maybe I can change the ISO. Okay, so electronics is installed in there. So everything is except extruder. Extruder I have to just tune a bit. So everything is installed, everything is working. So let's take the pliers and stop the filament flow and see what it's going to do. Now, error needs to occur 3 times in a row in order for this to work. So I'm right now I'm stop the filament with the pliers, and in a few seconds it should beep. Yep. So in 3 times in a row, printer, my microcontroller says, I see the slippage more than 20. I see the slippage more than 20. I see the slippage more than 20. 3 actions in a row, and I will stop the printer, because I don't want false triggers. Because if I have false trigger in the night or 12-hour, if I cannot reach the printer for a very long time, of course that will be no good, because now printer just stops and it's hot, and it's, of course, fans are working, so the filament will deteriorate, of course, for if you long like 1 hour or 2 hours. So it's not great. So right now it just stops, so I have to press play or resume, I guess, and printers keeps printing. So that's nice. So there's a lot of safety, as I said, included in this feature. So for once, error needs to occur 3 times. Error needs to occur when motor of the extruder is turned at least 5 seconds or more. I don't remember the code, and motors have to be all of these steppers for X, Y, and Z needs to be turned at least once in like 5 seconds. So because I don't want false trigger. So right now I never see the false trigger. I know that if my protection is on, my printer is stopped, something is wrong, something's horribly wrong. And usually I never extrude while pressing on the screen extrude. When it stops, it just lowers, and you can extrude or you can retract the filament to change the filament. So now of course Tornado drivers are on, except for extruder. It's much quieter. It's not even close to the Cetus 3D MK2 version, because it is open frame, so if part is resonating, it's not creating a lot of sound. In this, it's metal box, it's extremely heavy box. All the low noise, low frequency vibrations are amplified, so I have to put foam or something like that. So 2 modifications are still left. So one is for the spool holder. I will add with bearings and dampers, so make a precise hole, so it will turn on the axis and not turn and slip like it does right now. Like this one, there will be not that will be exactly with bearings, and I think the magnets to snap it on, so it will be very tight. And of course power supply for 220 to 24 volts, because right now it's external, it's very heavy, it's very bulky. I just want to have 1 cable for this printer. And now everything is inside the printer. You see the heads, one is missing because I'm rebuilding it, and extruder nozzles are also missing because I just installed a new one. So I'm very happy with the printer right now. It prints very silently. If I put it on the, if it's on the room, inside the room where I work, it's not a big deal. It's not, again, not even close to the C2 3D that I even can't hear it. But if I put it in the second room, I can't hear it, nobody can, so I can sleep and so on. And of course I'm printing PG, so it's not outgassing a lot of fumes. So I'm very proud of the work I did. It's very silent, well, as it can be. It has protection for the failed prints. It has, it has better bed now. I put the pay material and some other material from 3M. I know it's from GGKey. And it prints right now very good. And yeah, I'm very happy right now with this printer. But again, I will have to do some few modification to make it just perfect. So this board will be available to download, so all the source code, all the Gerbers, so you can change for any printer. And used again for this, I can show it to you, for this encoder. Also all the files, come on focus, all the files will be included, so you can download and print it or modify in any way. So you can replicate it on any other printer, because this board is it's universal for any printer. It's 4 dynamic drivers with intelligent power management and voltage mode PWM control. So there is no current feedback loop. There is only the very deterministic way of generating the sinusoid for the steppers. So thank you for watching, and I wish you all a good day.